Good morning, students. Today we will be discussing points and straight line. This is the next session on whatever we had discussed yesterday. In the last class we discussed about the different centers of a triangle and some important points related to those centers. Um, Today we will start discussing with area of a triangle. Okay, and then we will discuss about the area of a polygon. Now, before I proceed further, could you please confirm that you are able to hear me very clearly and
Yes.
and to view the screen properly, dear students?
Yes.
And I will request to mute yourself. Whenever you want to speak, please unmute and speak. Okay. So in area of a triangle, dear students, what we are going to discuss, when you know the, three coordinates of a triangle, how to find the area. You know, since, class 7th or 8th standard, we started solving, problems related to area of a triangle. And also we know how to find the area of a triangle. But today we are going to discuss the same topic, area of a triangle, by means of different, parameters. What are the other parameters we have learned so far? You have been given the three sides, okay, or you have been given the base and the altitude, okay. And in this manner, and also when we discussed about the properties of triangles in class 11, there also we discussed that, by means of how come you can find the area of a triangle by means of the circumradius and and the other characteristics like the sides and the angles. But today, what we are going to discuss, dear students, is that to find the area of this triangle by means of the coordinate geometry. So what does it mean in triangle, So there are three vertices, as you know, A, B, C, the way we name it. So let's consider the coordinate of the point AB, x1, y1. Coordinate of the point BB, x2, y2. And coordinate of the point CB, x3, y3. Now what we are going to do is that we are going to find the area of this triangle ABC. Okay. Now you can say one thing, sir, it is not a big deal. I can do it now because I know the distance formula. You can find the value of A, B, B, C and C, as you know the coordinates. And then you can find the semi-perimeter and you can apply the Heron's formula. But that will be, little, lengthy. So how we can do it efficiently? Because efficiency, we always discuss how we can achieve some result in an efficient manner. Okay. So keeping this in perspective, the area of a triangle, okay, is the value of the determinant is something like this, that area of this triangle, if we define delta be the area of the triangle, area of, let me write properly, delta is equal to area of the triangle ABC, and that is equal to 1 by 2 into a 3 by 3 determinant. That is, if I read row wise, it become x1, y1, 1. That is x1, y1, 1, x2, y2, 1, and x3, y3, 1. Now, dear students, if you recall, in one of our previous classes, we discussed about how to find the area of a 2 by 2 determinant, right? If you recall. Now, we can, convert these 3 by 3 determinants to be 2 by 2 determinants. So instead of remembering this, 3 by 3 determinant formula, we can do it in 2 by 2 determinants. How? So this same thing is equal to 1 by 2. It is a 2 by 2 determinant like this, x2 minus x1, x2 minus x1, and then y2 minus y1, then x3 minus x1, and y3 minus y1. Actually, dear students, this 2 by 2 determinant, what you see, this is actually obtained from this 3 by 3 determinant by using the properties of determinants. As you are not aware of these properties of determinants, I am not explaining how we have achieved it. But if you are, interested to know the determinants at this level, I really appreciate. I have some great video lectures available in YouTube and in the online test platform. You can at konarkclasses.com. You can go through it. And now, what does it mean actually? If you find that this is the pattern you should remember: 1 by 2 into x2 minus x1, y2 minus y1, x3 minus x1, y3 minus y1. Okay. So if you remember this thing, then it is very easy to find the area of a triangle. Now, as I said few minutes back, that once you know the coordinates of the 3 points of a triangle, you can find the length and you can apply Heron's formula, that is square root of s into s minus a into s minus b into s minus c, where s is the semi-perimeter of the triangle and ABC are the length of the 3 sides of the triangle. You can find it out. But that will take longer time than finding the value of this determinant. Let's take an example. Okay. Suppose a triangle is given to us with 3 coordinates, a become, let's take 2, 3, b is, we can take 8, 11, and c is the point, we can take it as that, 8, not 8, so let's take 4, 0. So what will be the area? Let's see, you compute the time, and that how much it is taking time to find the value of this thing. It will be very easy. So x2 minus x1, x2 is as if the coordinate, x coordinate of the point b, so x2 minus c1, that means 8 minus 2, and y2 minus y1, that means 11 minus 3, divided by x3 minus x1, that is 4 minus 2, and y3 minus y1, that is 0 minus 3. So this is equal to what, dear students? 1 by 2 into 6, here it is 8, here it is 2, and here it is minus 3. So this is equal to 1 by 2 into minus 18 minus 16. So that is equal to 1 by 2 into minus of 34. So that is equal to minus 17 square units. But area cannot be negative, so we consider the positive value. We considered the positive value. That is 17 square units. Got it, dear students? How to find the area of a triangle? Any doubt? Please do let me know. Now, from this concept, we can find the area of a polygon, okay, and very efficiently. We will discuss in separate class, how to find the area of a polygon by means of their internal angles and the length of their sides, okay, especially a regular polygon. But the point is that what we are going to discuss here, to find the area of a polygon when the coordinates of each of these vertices are given. Let us see one such polygon. Okay, so our next point of discussion is the area of a polygon. But before that, I would like to just mention the theory portion from the study material and just place it here. Let delta be the area of the triangle with coordinates of the vertices A, x1, y1, b, x2, y2, and c, x3, y3. Then we get the following: delta is equal to 1 by 2, x1, y1, 1, x2, y2, 1, x3, y3, 1. That is also equal to 1 by 2 into x2 minus x1, y2 minus y1, x3 minus x1, y3 minus y1. Now let's proceed. Let's proceed towards finding the area of a polygon, okay, when we know the coordinates of the vertices. Okay, so think about a polygon. I'm considering something like this, area of a polygon. And it is, in fact, you can only answer that how to find the area of a polygon using the concept of how to find the area of a triangle. Suppose we get a polygon something like this. Okay, let me name it A, B, C, D, E. Okay, this is a polygon. Now we know the vertices of we know the coordinates of each of these vertices: A, x1, y1, B, x2, y2, C, x3, y3, D, x4, y4, and E, x5, y5. Or let me write the coordinate of E here outside this polygon. Now x5, y5. Now, could you please tell me, someone of you, that how to find the area of this polygon? What is the best approach you can take based on the knowledge we have?
So we can divide it into triangles.
Correct, exactly. We can divide into triangles, and the way you can do it is that you can divide like something like this. Correct? Oh, sorry. In the digital board, the problem what I face is that to draw a straight line properly. In pen and paper, I can draw very well, but in digital board, I face problems. So now, dear students, if you find, so now we, we construct that, we make this, polygon divided into three triangles. The first one is ABE, second one is BCE, and third one is DCE. Now, as we just learned how to find the area of a triangle, we can apply the same concept to find the area of this three triangles, and then add it up, and we'll get the area of the polygon. Correct, dear students? I hope you got it, that how to find the area of a polygon. Okay, now from here, so let me just copy paste the relevant study material, and it is exactly says what I just explained to you. So as you see in the notes, it says that if the coordinates of all the vertices of a polygon is given, the area of the polygon can be calculated by dividing the polygon into a number of triangles, and then sum up the areas of all these triangles to find the area of the polygon. As you see in this example, there is a hexagon A, B, C, D, E, F, and A, because I complete that hexagon by reaching to the point A again. We can find the area of this hexagon by dividing it into four triangles, as shown. You see that there are four triangles: 1, 2, 3, 4. As the area of the hexagon will be, and we find the area of the hexagon as the sum of the areas of all these four triangles. Now, dear students, we can from the area of a triangle, we can also use that formula to find whether the 3 points are collinear or not. Think about, dear students, if 3 points are collinear, what does it mean? That means that they are in the same straight line, correct or not? So if they are in the same straight line, and if you construct a triangle, first of all, you cannot construct a triangle when the 3 points are in the same straight line. But analytically, you can think that if you apply the formula of the area of the triangle for these 3 points, what you will get? You will get 0. Correct, no? So what I'm saying is that suppose we are going to find whether the 3 points on this straight line are collinear or not. Collinear means they are in the same line or not. Suppose this is the point A having coordinate x1, y1. This is the point B having coordinates x2, y2. And this is the point C having coordinates x3 comma y3. So now suppose we do not know when these three coordinates is given to us, we do not know whether they are collinear or not. Okay, but what has been asked to us? Find whether these three lines are collinear or not. Now, one thing I can say is that, okay, if they are not collinear, I repeat, then we can construct a triangle and we'll get some value of that area of that triangle. No? So let's find the area of that triangle. Okay. If we find the area of the triangle, dear students, what we understood? 1 by 2. It is x2 minus x1, x3 minus x1, y2 minus y1, y3 minus y1. Correct or not? y3 minus y1. Now, if they are in the same line, then we are not able to construct a triangle. That means what? The area of the triangle, analytically, we can find that value is 0. And that is a proof that these 3 points are in the same line. So, dear students, the easiest way to find whether the 3 points whose coordinates are given are in the same line, that is, whether they are collinear or not, the best approach is to find the area of the triangle by means of computing this small 2 by 2 determinant and find the value, and you will get 0. If you do not get 0, then you can say no, these 3 points are not collinear. And if you get 0, then you can say with full confidence that these 3 points are collinear. Now, dear students, as we study other stuff from the straight lines, we will see there are other methods also to find the collinearity of 3 points. Okay, and that we will learn. That is also these methods are also efficient, but this is one of the efficient method we have learned so far. This is the best method what we have learned so far. Now, once you learn some other methods in future, then you can judge which one to take. I will give you the liberty that you decide which one you want to choose. Okay, but this is one of the efficient method to find the collinearity of 3 points. I hope it is clear, dear students. Now, any difficulty, please to let me know. Any smallest doubt, never hesitate. Okay, and these are the points you need to certainly remember, dear students. Uh, and uh, and I'm now moving to a new discussion, and that is a very interesting topic. I hope you will enjoy it and you will like it, and that is called the reflection of a point with respect to a straight line. Okay, a reflection of a point with respect to a straight line. Let me explain you the problem little bit. Okay, what is mean by that? What is mean by this reflection of a point with respect to a straight line? Okay, so think about that. A point has been given to you. Okay, and the coordinate of the point be alpha comma beta. Okay, suppose there is a point P is given to you with coordinate alpha comma beta. Now you have been given one straight line. You have been given one straight line. Okay, dear students, could you please give me 1 minute, please? I'm just taking a break for a minute.
Yes.
Yeah, dear students, I come back. Sorry. So now what I was telling, suppose let's take that point P, B alpha, comma beta, whose coordinate is given to us. Now you see the blue line, okay, that is a straight line. Or better, you consider this is a mirror. Then what will happen? You will get, you will find the, a reflection of this point somewhere here in Q. So where will be the reflection? So let me take the reflection point will be Q here. Correct or not? And the coordinate of that point QB gamma comma delta. Okay. And what is our task? Our task is that if the equation of the straight line is given, suppose the equation of the straight line is given as, ax plus by plus c is equal to 0. So what is the equation of the straight line? Ax plus by plus c equal to 0. We'll come to this one, the general equation of straight line, all these points we will discuss. But the thing is that alpha comma beta is given to us. Okay. Alpha comma beta is given to us, means the coordinates of the point P is given to us. The equation of the straight line, that is ax plus by plus c, that is given to us. But what we need to find, dear students, we need to find what is the coordinates of the point Q, that is gamma comma delta. We need to find it out. There are many ways to find it out. Okay, but the best approach, and as I always say, dear students, I give which is very efficient way we can find it out. Okay, so think about before telling you the formula, relevant formula. Suppose that straight line ax plus by plus c, you can move it, na? If you move it, and keeping the point P alpha beta fixed, you will see the point Q also move. So there are two objects here. One is the point P and another is the straight line ax plus by plus c. Suppose we give that name of the straight line as L. So there is a point P and there is a straight line L. You can move both the objects, that is P you can move, L, P and L both you can move at the same time. Or you can move P, you can keep L fixed. Or you can move L, you can keep P fixed. But in all these cases, what will happen, dear students, that you will see the Q will get changed. The coordinates of Q will get changed. Okay. So how efficiently we can find the value of the coordinate of Q, that is gamma comma delta. And the best approach, dear students, to find the coordinate of this, point Q, that is gamma comma delta, is to find this. You just remember this thing. Let me use a different color. That is gamma minus alpha by A is equal to delta minus beta by B, that is equal to minus of 2 into A alpha plus B beta plus C divided by A square plus B square. Now if you see, dear students, that minus 2 into A alpha plus B beta plus C by A square plus B square, you can compute because all are given to you. ABC you know, alpha beta you know, so you can compute the value of minus 2 into A alpha plus B beta plus C by A square plus B square. And you know alpha and A, so from there you can easily find the value of gamma. And in the similar manner, you know the value of beta and B, from there you can easily find the value of delta. That is the most efficient approach of finding the coordinates of a point, which is reflected by a point with respect to a straight line. Correct, dear students? Okay, and you need to remember this thing. If you remember, you can answer it very efficient manner. You will find later when you will start solving numericals, you will see that if you do not remember, then also you can solve it, dear students, but it will take longer time. And that is not preferable as long as your entrance examination is concerned, because their time is limited. Now, dear students, suppose you do not remember the formula, that is gamma minus alpha by A is equal to delta minus beta by B is equal to minus 2 into A alpha plus B beta plus C by A square plus B square. How to achieve it? Or you can say, sir, how you found out this formula? How you come to this formula? That is also a very valid question. Okay. And those you can look into it and we can take it offline, because here I teach only what is very relevant. Okay. Point is that suppose you do not remember the formula and a question like this has come to your exam. Then how to do this thing? So first you need to draw a perpendicular, right? So what you need to do, you need to do a perpendicular from, you join PQ, and you know that PQ is perpendicular to the line L. And if M be the, suppose, you know, the point of intersection of that PQ and L, then PM equal to QM. Right? All these things you need to do. And then you find, by solving, you know, big equations, you need to find the value of gamma and delta, which is not at all efficient. I'm not telling that you cannot do it. You can do it, but it will not be an efficient method. What is the efficient method? Efficient method is that to find that whatever I just said few minutes back, that is gamma minus alpha by A is equal to delta minus beta by B is equal to minus 2 into A alpha plus B beta plus C by A square plus B square. And not only that, there is a way you can remember this thing. What is that? Your equation is AX plus BY plus C equal to 0, na? So just apply instead of X alpha and instead of Y beta, then you will get A alpha plus B beta plus C, that you write, and minus 2 you multiply divided by coefficient of X square plus coefficient of Y square, that is A square plus B square. And what is gamma and alpha? Gamma and alpha is nothing but the X coordinates of the point Q and P. So you do gamma minus alpha by A that is equal to, and A is nothing but the coefficient of X of the relevant equation of the straight line. Similarly, delta minus B, what is delta minus delta and B? Delta and B is nothing but the Y coordinates of the point Y, B, Q and P. So delta minus beta by B, what is B? B is the coefficient of the Y in the given equation, Ax plus By plus C is equal to 0. And in this way, you can find the reflection of a point with respect to a straight line. Correct, dear students? So you need to remember this formula. I repeat once more that if you remember this formula, you will be able to answer this question, very relevant question, very efficiently. Okay, dear students, now what we are going to discuss, another interesting point is that it's called the slope of or gradient of a line. Okay, many of you are aware of it, slope or gradient of a line. But here I'm going to tell you that how we can find the slope or gradient of a line when the 2 points, are given. How you can find the gradient of a line when the 2 points are given, and you are going to find the gradient of a line, passing through these 2 points. Why I'm telling about these 2 points? Dear students, the very generic statement, as we are discussing straight lines, about to discuss straight lines, we are in the process of discussing points and straight lines. One thing is very important is that to construct a straight line, you need exactly 2 points. Or more specifically to say, to construct a straight line uniquely, okay, you need exactly 2 points. Okay, suppose if I give you only 1 point, okay, and you can construct many straight lines passing through this, correct or not? But if I give you 2 points, impossible. You can only construct only one straight line. It is impossible to find any other straight line. So that is why, and we will see why it is so. Why it is so, one thing to from geometry you are able to find it out, and from algebraic point of view also we will discuss later that why it is so, because there are 2 independent variables. Okay, and as there are 2 variables, we need 2 clues, 2 information should be given so that we can determine the straight line uniquely. We'll discuss all these things in details, but what is the present point of discussion is that the slope or gradient of a line. Dear students, if you recall the coordinate axis and a straight line, so how it looks like, all of you are aware of what is gradient, but here also we can find the gradient by means of the coordinate geometry. So suppose this is the coordinate axis what I drawn in the green color, and now suppose there is a straight line. This is a straight line what I draw in blue color. That is a straight line L. Now this straight line, what is gradient or slope? Suppose first we need to find the inclination. There is a term called inclination. Suppose this straight line L makes an angle theta with the positive direction of x-axis. Then this theta is known as inclination. Okay. Now what is slope or gradient? Slope or gradient is nothing but tan of that inclination. Okay, so what is here? Inclination is theta. Inclination is theta. Slope or gradient is generally denoted by m, and you know, dear students, what it is? It is tan of this angle. But remember means you know, I know, but I'm just repeating the statement that theta has to be measured anti-clockwise direction, which is a positive direction. Okay, anti-clockwise direction is known as the positive direction of measuring angle, dear students. So this is the way we find the slope or gradient of a line. We know this thing, but what we are going to do here? We do not know theta. Theta is not given to us. What is given to us? It has been given to us is that, suppose, let me draw that straight line. Okay, suppose a straight line is given and coordinates of 2 points are given to us. Okay, equation of the straight line is also not given to us, but it has been informed to us, okay, that straight line is passing through 2 points. One point is x1, y1, and the other point is x2, y2. Okay, can we find the gradient of this line? We can say yes, we can. How? The gradient here, m is equal to that y2 minus y1, that is the difference of their y coordinates, divided by x2 minus x1. That is the difference of their x coordinates. So this is the way we find the gradient of a line when the 2 points on that line, coordinates of the 2 points on the line are given. So that means what? And we can derive also. So you can say if that straight line is making an angle theta. So suppose, let us consider this straight line L only, and we get 2 points here. Okay. One point is A with coordinates x1, y1, and another point B with coordinates x2, y2. Then what we can say? M is equal to tan theta, as we already derived. M is equal to tan theta, na? Okay, and we also find m is equal to y2 minus y1 by x2 minus x1. So combining these two, what we can say, dear students? Combining these two, we can say then m is nothing but tan theta, and that is also equal to y2 minus y1 divided by x2 minus x1. I hope it is clear, dear students, that how to find the gradient or slope of a straight line. Very important point, that how to find the gradient and slope of a straight line. Okay, now dear students, what I'm going to discuss the transformation, translation and rotation of coordinate axis. Okay, now the first point what I'm going to discuss is the translation of coordinate axis. Okay, so what is meant by that? Let us understand first. Okay, so the topic what I'm going to discuss now is the translation and rotation of coordinate axis. Translation and rotation of coordinate axis. Translation and rotation, what is meant by that? Okay, so let us first construct a coordinate axis. Okay, so this is our coordinate axis, x, o, x dash, y, o, y dash. Okay, dear students. Now, what is happening is that, suppose with respect to this fixed coordinate system, we have a point, and that point P is having a coordinate, we can say x comma y. Correct? Now what we are saying is that we want to translate that coordinate axis. What is meant by translating the coordinate axis? That, we are moving that x and y axis. The framework remains the same. That means they are vertical. X dash o x, y o, y dash o y. These are fixed. Means their relative angle is fixed. That is 90°. But what we are doing is that we are shifting them. As if I describe in a different color, so we shift them to a new coordinates. Okay. So this becomes what you see, the new coordinate axis. That means what? For the sake of simplicity, what we can do is that we can write, okay, the original coordinate system, what we are seeing is that it is lowercase x, lowercase y. Okay, so let me first write it down and then explain it. So suppose it is x, sorry, let me use a different color. Okay, so this is x o x dash lowercase, and this is y o y dash. Okay, now we move this coordinate axis to a new point. What is the point? Suppose we move this point to a point called A, and that point A having a coordinate, suppose h comma k with respect to the previous coordinate system, that is lowercase x o x dash, lowercase y o y dash. But our new coordinate axis, which you see, dear students, in a green color, that is capital X, we can make this thing is that A and capital X dash, and capital Y, A, Y dash, as if that A becomes the new origin. Correct or not? Then the question is that point P, which was having a coordinate called x comma y with respect to the previous coordinate system, what will be its new coordinates with respect to the new coordinate system x a x dash and y a y dash? This is what is called translation of coordinate axis. This is what is called translation. Now, what is rotation, dear students? Rotation is something different. Okay, so what we discuss now is that is called the translation. This is known as translation. So first I explain that what is meant by translation and rotation. Translation means is that you are just moving a rectilinear motion, rectilinear movement. Okay, that means what? You just make it in a shifting. Okay, from x o x dash y o y dash to a point called x, to a position called a capital X dash, capital Y a capital Y dash. And as you moved like this to a new origin with coordinate h comma k with respect to the previous coordinate system, then what will be the new coordinate of this point P with respect to the new coordinate system? That is the point of discussion. That means that pxy, so now it become what? That suppose new coordinate become x dash comma y dash. What will be the coordinate of x dash comma y dash? That is the point of discussion that we will discuss. Now let us understand what is meant by rotation. Okay, so let us understand rotation now. So now suppose we have a coordinate axis. Okay, so this is x o x dash and y o y dash. What we are doing, dear students, is that we are now rotating that entire framework in a counterclockwise. Okay, suppose we rotate that entire framework counterclockwise. That means what? Our new position, origin remains the same. With respect to the origin, we are moving. So that means our new x-axis become this, and our new y-axis this becomes a new y-axis. Sorry, as you know that my drawing is not proper when it is a digital board. That is the only disadvantage of digital board what I am facing. Otherwise it is fantastic. Yeah. Okay, so this is my new y-axis. So as I did in the previous case also, so let me write that previous axis as lowercase, okay, and new will define as a uppercase. So that is lowercase x o x dash. Sorry, let me use a different color. So here it is x o x dash, and here we get y o y dash. And what is the new coordinate we are getting, dear students, is that capital X O X dash and capital O Y dash. And in which angle it is actually moved? It moved in an angle of theta, anti-clockwise direction. Now think about a point P, okay, with respect to the original coordinate system. So let me use a different color. So there is a point P with respect to the lowercase x o x dash y o y dash. That means the coordinate axis which is in the red color. So suppose with respect to this the original coordinate axis, the point P was having a coordinate called x comma y. Now we made a rotation. That means we made a rotation of the coordinate axis at an angle theta, anti-clockwise direction. Then the point remains the same point, but its coordinates will get changed with respect to the new coordinate axis, which is in the green color, now dear students. So suppose with respect to the new coordinate system, the point P is having a coordinates x dash comma y dash. So our target is to find what is the value of x dash and y dash in terms of x, y, and theta. And that is in case of the rotation, that is called the rotation. Okay, dear students. And in case of translation, our target is to find the value of x dash and y dash in terms of x, y, and hk. Correct, dear students? So what is our target? Our target in the translation I explained that coordinate axis moved in a rectilinear position. Rectilinear movement has happened so that the new origin become the point h comma k with respect to the previous coordinate system, and we want to find the value of the coordinates of the same point P with respect to the new coordinate system in terms of x, y, h, k in case of translation. And in case of rotation, when we actually rotated the coordinate axis in anti-clockwise direction by an angle theta, then we need to find the coordinates of the same point P with respect to the new coordinate system, and it should be expressed in terms of x, y, and theta. And that we are going to discuss now, dear students. So I hope you got what is meant by translation and what is meant by rotation. Dear students, is that the new coordinate system, that is in case of translation, what I can write is that in case of translation, what we get, dear students, we get x dash is equal to x minus h, and y dash is equal to y minus k. Okay, so if you know the, not if you know the value of x, y, and hk, and you can find the value of x dash, y dash easily. Correct? Now, sometime in the question, it will be given like this, a point is actually translated, coordinate axis of a point, has been translated to a point h comma k, and we got the coordinate of the point P with respect to this, new coordinate system as h dash, x dash comma y dash. Find the value of the coordinates of the same point P with respect to the old coordinate system. That means you need to find x, y in terms of x dash, y dash, hk. So that you can always find it out from this equation, right? Whatever I just wrote, x dash equal to x minus h, y dash equal to y minus k. But the most straightforward discussion is that because with respect to the old coordinate system, we know what is the value of x and y, and as it moved, as the coordinate axis moved rectilinear way and moved to a point comma h comma k, and h comma k becomes the new origin, and h comma k is the coordinate of the point A, as you see here, dear students. Okay, with respect to the old coordinate system, then we can find the value of x dash and y dash. Now, what about rotation? So, how we can find the value of x dash and y dash in terms of in terms of x, y, and theta? That we are going to discuss, dear students. So the point is that to find this one, what will be our next, new coordinate is that the new x dash become x cos theta plus y sin theta. X cos theta plus y sin theta. And new x dash, sorry, I'm so sorry, and new y dash become x cos theta, y cos theta, sorry, y cos theta minus x sin theta. So that means x and y are known to you, theta is known to you, you can find the value of x dash and y dash. And dear student, there is an interesting point. In case of translation also I expressed that suppose x dash and y dash is given to you and you need to find the value of x, y, and theta is also given to you, by the way. Suppose x dash is given to you, y dash is given to you, and theta is also given to you. And you need to find x, y. That means you need to find the coordinates of the point before rotation. How to find it out? So then you can say, sir, it is not a difficult task because it is a linear equations of two variables. I have two unknowns, x and y. X dash, y dash known to me, theta is known to me. Here it is a linear equations of two variables, I can solve it out. Yes, correct answer. But how efficiently you can do it? What is the efficient manner? And for that, this is the one I'm going to express actually. Is that we can write it here, x dash, y dash. So this table, if you can remember, everything else will be very, very clear. So here we are telling that x dash, y dash, and here we are telling x and y. So what we are going to write here, dear students, here it is cos theta sin theta. So let me write it in a different color. So here I will write cos theta sin theta, and here you will write minus sin theta cos theta. Minus sin theta cos theta. Now, dear students, if you remember this table, then theta is known to you anyway. Then you can find the value of x in terms of x dash, y dash theta, or x dash in terms of x, y, and theta. How? So from this table, how we can form it? So this table actually tells you, from this table what you can write is that you can write x is equal to x dash cos theta plus, sorry, x dash cos theta minus y dash sin theta. Correct, no? And why you can write is that, so you understood x is equal to x dash cos theta. X we are going to find x dash cos theta plus y dash into minus sin theta. That means x dash cos theta minus y dash sin theta. Similarly, we can find y is equal to x dash sin theta plus y dash cos theta. This is the way you can find it out, that x and y. And we already found it out, x dash and y dash, from the similar manner from this table. that x dash equal to x cos theta plus y sin theta, and y dash equal to minus x sin theta plus y cos theta. So this is about the translation and rotation, dear students. Now, what will be best is that if we can solve couple of problems together. Okay, so let's solve a problem. Okay. So the first question what I'm going to give is something like this. So you please open your notebook. So we will solve these questions together. Okay. The first question is in front of you, dear students, is something like this. The question here, find the transformed equation of the straight line. Okay, let me give this one very properly, dear students. Just a minute. Yes, this is the first question, dear students. So here the question is, find the transformed equation of the straight line x by a plus y by b is equal to 2 when the origin is transformed to the point a comma b. Now, dear students, as we know that when the origin is transformed to the point a comma b, that means what is our new equation? X dash is equal to, x minus a, and y dash is equal to y minus b. Correct or not? Correct. So what is our original equation? So our original equation is something like this. Let me write it out here, dear students. So x by a plus y by b is equal to 2. Okay. Now, what happened? The transformation happened. Now, in the transformation, if any point P is there on that straight line with coordinate x comma y, and that point become, now the coordinate of that point becomes, so it remains the same point, but its coordinates now become x dash comma y dash. So what we know? We know that x dash is equal to x minus a, and y dash is equal to y minus b. So from these two, what we can conclude? So this implies 1 by a, what is x? X become x dash plus a, plus 1 by b, y is equal to y dash plus b, that is equal to 2. Correct, not, dear students? So from here, what we can say, x dash by a plus y dash by b plus a by a is 1, a b by b is 1, that is equal to, that is plus 2 is equal to 2. Correct? Since, a is not equal to 0, b is not equal to 0, because if a is equal to 0 and b is equal to 0, the question doesn't make sense. So then what we are getting, x dash by a plus y dash by b is equal to 0. This is a new equation. This is the, transformed equation. Instead of saying the new equation, transform equation is the most appropriate word, dear students. So this is the transform equation whose original equation is x by a plus y by b is equal to 2, and when the origin is transferred to the point a comma b. If I describe this problem in picture, how it looks like. So this is the original coordinate system, dear students. X O x dash, okay, and y O y dash. Then what happened is that it has been shifted. It has been shifted to a point what? A comma b. So this becomes our new coordinate system. Okay, just a minute, let me. So this is capital X, that is the point, suppose A, whose coordinate is a comma b, and that is capital Y, that is capital X dash, and this is capital Y dash. Then with respect to the previous coordinate system, we had a straight line. That is, straight line was something like this. It is the straight line equation, I can say, something like this. Okay, that is the original straight line, whose equation is, original straight line means straight lines remain the same, it doesn't change, but its equation gets changed with respect to the difference coordinate axis. With respect to the the previous coordinate axis, its equation was what? Its equation was x by a plus y by b equal to. So I use the same color, the color of the coordinate axis. So the coordinate axis with respect to the equation of the straight line with respect to the previous coordinate axis was x by a plus y by b is equal to 2. Now with respect to the new coordinate axis, which is in the green color, its equation become x dash by a plus y dash by b is equal to 0. Correct, not, dear students? I hope it is absolutely clear. Okay. Sorry. Now, let us solve a problem with respect to a question related to the rotation of the coordinate. This is about the translation, what we just discussed. Now, let's solve a problem with respect to the rotation. Sorry. So, dear students, this is the second question, and let's see how we can approach this question. Okay. So, what is the question here? Find the transformed equation of the curve x square plus 2 into root 3 into xy minus y square minus 2 equal to 0 when the coordinate axes are inclined at 30 degree to the original axis. That means, let us first draw the diagram. Okay, so let us draw the previous coordinate system, the original coordinate system in the blue color. So that means what? It is like this: x lowercase o x dash, lowercase y o y dash, and with respect to this coordinate system, we have a curve. Okay, so suppose the curve is, I'm drawing in this red color. Suppose this is a curve, and this curve is something like this. It may not be exactly looks like this, but our point of discussion is not the what is the curve exactly looks like. Then what happens, dear students, is that now what we are doing, we are rotating that coordinate axis with an angle of 30 degree. Okay, with the original axis. That means what? By new x-axis will be something like this. That is capital X O, capital X dash. And similarly, what happened is that y-axis should also get moved by same 30 degree. Correct? So what we get is that this we get capital Y O Y dash. Okay. And this angle is 30 degree. This angle is 30 degree. Now the question is that with respect to the new coordinate system, which is in the green color, what will be the equation of this curve? What is the original equation of this curve? Let me write it in the in the blue color, because blue color is the original axis. So that is equal to x square plus 2 into root 3 into xy minus y square minus 2 is equal to 0. Now what we are going to do, dear students, we are going to find the equation of the same curve with respect to the new coordinate system, which is in the green color, and the new coordinate system is at an inclination of 30 degree with the original coordinate system, which is in the blue color. Okay. Now, dear students, if you recall that formula, that what is x dash? X dash is equal to x cos theta plus y sin theta, and y dash equal to y cos theta minus x sin theta, as you see it here. Okay. But what we are going to do here, dear students, is that we are going to find x and y in terms of x dash and y dash, and that we apply in the value. So what is x is equal to? So we need to apply this particular formula set. So what is that? X is equal to x dash cos theta minus y dash sin theta. Correct? So what we can write it here, dear students? So x equal to x dash cos theta. What is theta here? Theta is 30 degree. X dash cos 30 degree minus y dash sin 30 degree. And if you find this value, so this gives, and this is equal to, you are getting that 1 by 2 into x dash into root 3. So we can write is that root 3 into x dash minus y dash. Correct, dear students? And what is y? Y is equal to x dash sin 30, x dash sin theta, that is x dash sin 30 degree, plus y dash cos 30 degree. That is equal to what? That is equal to 1 by 2 into sin 30 and cos 30, which we apply the value here, is that it will become x dash plus, root 3 into y dash. So what is our original equation, dear students? Original equation is x square plus 2 root 3 into xy plus y square minus 2 is equal to 0. So our original equation is x square plus 2 into root 3 into xy minus y square minus 2 equal to 0. Now here, what we are going to find? We are going to find what is the transform equation due to this rotation of the coordinate axis. So instead of x, we will write 1 by 2 into 1 by 2 into root 3 into x minus y dash whole square, complete whole square, by the way, this complete whole square, plus 2 into root 3 into 1 by 2 into root 3 into x dash minus y dash into 1 by 2 into x dash plus root 3 into y dash minus y square. So minus 1 by 2 into x dash plus root 3 into y dash complete whole square minus 2 is equal to 0. Correct or not? Now, what I want you to do is that you to do the simplification. Okay, I'm not spending time in simplification because it is very easy algebraic simplification. And you will get something like this: x dash square minus y dash square is equal to 1. And this is the equation of the, curve with respect to the new coordinate system. So with this, dear students, I would like to conclude the class. But before concluding, I would like to give you a question, and that question you can solve it and do let me know before we start our next class. Okay. And here is the question. Please, you can take a note of it, or anyway, you will get it over the, the question what I'm going to give it to you. That's, the class note. You will get it through the class note as well. And this is the question you need to solve and send it to me before we start our class day after tomorrow. And the question is something like this, dear students. Find the angle through which the axis are to be rotated, so that the equation x root 3 y x root 3 plus y plus 6 equal to 0 may be reduced to the form x equal to c, and determine the value of c. So this is the question. You need to solve it, question number 3, and do let me know. So I repeat the question once more. Find the angle through which the axes are to be rotated so that the equation x root 3 plus y plus 6 equal to 0 may be reduced to the form x equal to c, and also you need to find the value of c. So you need to find the value of the angle. If theta is the angle, you need to find the value of theta, and also you need to find the value of c. I will appreciate if you can work on this problem and do send me your solution by today. With this, I would like to conclude the class, dear students, unless you have any specific question for me. Okay. Thank you very much. And